Febco's Model 825Y Reduced Pressure Backflow Prevention Assembly is the ultimate in mechanical protection of potable water against hazards of cross-connection contamination. Cross-connections are any point on a water system where a contaminating substance may come in contact with the potable water. The 825Y is used in high-hazard applications, such as those found in industrial plants, hospitals, irrigation systems, morgues, boiler feeds, chemical plants, and water lines needing maximum protection from a contaminating substance which may come in contact with potable water, creating a health hazard, causing sickness, or even death. The 825Y meets or exceeds all specifications of the USC Foundation for Cross-Connection Control and Hydraulic Research, the American Water Works Association, the American Society of Sanitary Engineering, and the Canadian Standards Association. The Model 825Y reduced pressure assembly consists of two independently acting spring-loaded check valves, separated by a differential relief valve. During normal operation, the pressure in the zone between the two checks is maintained at a lower pressure than the supply pressure. During a no-flow condition, if either check valve should leak, the differential pressure relief valve could discharge to atmosphere to maintain a pressure differential of no less than 2 psi between the supply pressure and the zone between the two checks. The unit also has inlet and outlet shutoff valves located upstream and downstream of the checks, in addition to 4 test cocks for field testing. Febco's 825Y is rated to 175 psi working pressure and operates in water temperatures ranging from 32 degrees Fahrenheit to 140 degrees Fahrenheit. Outstanding features of the Model 825Y reduced pressure device include the Y-pattern body design for low pressure loss, reliable operation, and easy serviceability. In a flow condition, the check valves of the 825Y are open, with the pressure in the area between the checks, called the zone, being maintained at least 5 psi lower than the supply pressure. The relief valve is hydraulically maintained closed by supply pressure. When abnormal conditions arise, such as fouling of the first check, under no flow or reversal of flow, the differential relief valve will open and discharge to maintain the zone at least 2 psi lower than the supply. In resumption of normal flow, the zone's differential pressure will resume and the relief valve will close. Proper installation of the 825Y is essential. The following are important characteristics of a proper installation. The 825Y should be installed in a horizontal position with a minimum clearance of 12 inches between the relief valve discharge port and floor or grade, and a minimum of 18 inches clearance around the unit for ease of testing and maintenance of the relief valve. Approval agencies do not recommend installation of a reduced pressure assembly in a pit. Flooding of the pit can result in cross-connection contamination. If local codes permit installation of a reduced pressure assembly in a pit, adequate drainage must be provided to prevent the pit from flooding under maximum discharge conditions. Placement of the assembly should be planned where discharge will not be objectionable and can be positively drained away with the use of an air gap drain into a properly sized floor drain. Febco manufactures an air gap drain model AGD-Y for use with the Model 825Y to drain away minor discharge or dripping from the relief valve. Make sure the assembly is easily accessible for testing and maintenance. If installed in regions of the country where extreme temperatures occur, protect the device from damage caused by freezing. Use of heat tape and a protective enclosure or other methods that allow adequate freeze protection should be used. If the unit is installed where vandalism may be a problem, the handles of shutoff valves and test cocks can be removed to discourage tampering, and a protective cage can be installed to prevent vandalism. To be a USC-approved device, the 825Y assembly must be purchased and installed with resilient seated shutoffs to ensure tight closure for more consistent results during testing. Also, because the 825Y is designed to be serviced in line, the unit should not be removed from the line during servicing. Union connections between the shut-off valves are not necessary, since the unit should not be removed from the plumbing system. Ensure that the supply water pressure does not exceed the maximum water pressure of the device to avoid damage to the system or the device caused by system pressure, water expansion, extreme back pressure, or water hammer. The importance of ensuring that the system and backflow prevention assembly are flushed clean when installing the device cannot be overstated. Most field problems occur because of dirt and debris present in the system at the time of installation that becomes trapped in the first check seating area, resulting in a continuous discharge from the relief valve in a static or backflow condition. The system should be flushed before the device is installed. However, to effectively flush the system after the device has been installed, remove the internal components of both checks and open the inlet gate to allow water to flow for sufficient time to flush debris from the line and device. Backflow prevention assembly should be tested regularly to ensure proper protection is being achieved. Most areas now require annual or biannual testing programs. Febco's Model 825Y reduced pressure assembly is designed for ease of testing. Testing is usually required by local officials to ensure the backflow assembly continues to operate in a manner specified by local codes. The equipment required to test the 825Y is a differential pressure gauge kit. The Febco Model 825TK test kit is available for this purpose at your local distributor. The purpose of the following testing procedure is to check the operation of the differential relief valve and the check valves. To be operating properly, the differential relief valve must keep the zone between the two checks at least 2 psi less than the supply pressure. Close number 2 shutoff valve on the discharge side of the backflow preventer and slowly bleed all air from the check valves in the manner shown. Insert the test fittings. Connect the high side of the differential pressure gauge to test cock number 2 and the low side to test cock number 3. Open test cock number 2 and test cock number 3 and bleed all air from the hose and gauge. Slowly open the bypass needle valve until the differential gauge needle starts to drop. Hold the bypass in this position and observe the reading on the gauge at the moment the first discharge is noted from the relief valve. The differential pressure at the time the relief valve opens must be no lower than 2 psi. Close the bypass needle valve. When testing the first check valve, make sure the pressure indicated is at least 3 psi more than the relief valve opening pressure. Begin by observing the differential gauge with bypass needle valve closed and test cocks number 2 and 3 open. The gauge should remain at a reading of at least 3 psi above the relief valve opening point. If it drops below this, the check valve is leaking and must be serviced. It is essential for check valve number 2 to be tight against reverse flow under all pressure differentials. To test for this performance, connect the bypass hose of the differential pressure gauge to test cock number 4. Then open test cock number 4. With bypass control valve number 1 open and bypass control valve number 2 open and the needle valve closed, observe the gauge reading. The differential pressure should not drop to the relief valve opening point. When these procedures are complete, restore all valves and test cocks to their original positions and return the valve to service. Febco's Model 825Y will usually show consistent operation throughout the preceding field testing procedures. In the rare case that it does not, the following troubleshooting procedures will help in restoring the unit to service. Before reviewing service procedures, it is important to note that Febco assemblies are serviced with commonly available tools and are designed for ease of maintenance. The assemblies are designed to be serviced in line, so the unit should not need to be removed from the line during servicing. A quick review of the most common causes of check valve fouling and relief valve discharge will save you time and effort during servicing. The most common cause of check valve fouling is dirt and debris on the seats. Also, worn or damaged parts, including the seat disc, O-rings, and disc holder, can cause the unit to malfunction. The diaphragm itself may leak if stretched or cut. It is important to note that if, during any of the following service procedures, it is found that the check valve seat disc has been severely cut along the seat disc ring diameter, the assembly is being subjected to extremely high back pressure from thermal water expansion, water hammer, or other causes of excessive water pressure. If the 825Y has a continuous discharge from the relief valve in a no-flow condition, slowly close the downstream number 2 shutoff valve and check the differential pressure across the number 1 check valve. A reading of 2 to 3 psid indicates the cause is a leak in the number 1 check valve. To determine the probable cause without the use of a differential pressure gauge, slowly close the downstream number 2 shutoff valve and open test cock number 4 to create a flow greater than the relief valve discharge. If the first check is fouled, the relief valve discharge will stop. If the 825Y has a continuous discharge from the relief valve in a flow and no-flow condition, slowly close the downstream number 2 shutoff valve and check the differential pressure across the number 1 check valve. A reading of 6 to 8 psid typically means the pressure relief valve is malfunctioning. To determine the probable cause without the use of a differential pressure gauge, slowly close the downstream number 2 shutoff valve and open test cock number 4 to create a flow greater than the relief valve discharge. If the discharge volume does not change, the pressure relief valve is malfunctioning. If the 825Y is experiencing intermittent discharge from the relief valve during a no-flow condition, check the differential pressure across the number 1 check valve. If the pressure reading fluctuates between 2 to 7 psid, it indicates an inlet pressure that is fluctuating. A reading of 2 to 3 psid means the number 1 check valve is being held open, and a reading of 6 to 8 psid indicates a malfunctioning pressure relief valve. Confirming of inlet pressure fluctuation is provided by installing a pressure gauge on the number 1 test cock. The line pressure fluctuation will be 5 psi or more. If your testing procedures indicate a malfunction in the valve, begin service procedures for these symptoms by disassembling the appropriate check valve. The following are procedures to follow. Slowly close first the inlet and then the outlet shutoff valves. Bleed the residual pressure in the assembly by opening number 4, 3, and 2 test cocks. Unscrew the cap by using the appropriate sized wrench. Retain the cap with the appropriate amount of hand force. Inspect the guiding bore of the cap for any buildup of calcium or other salts. If this condition exists, it may be removed with the careful use of an appropriate sized reamer or a thin blade knife. Rinse the cap thoroughly with clean water after removing the deposits. Debris can often inhibit proper disc holder stem movement in the guide. These parts must move freely. As you remove the spring and disc holder assembly, check the valve seat discs and check the seating area for debris and damage. Disassemble the disc holder by grasping the assembly in one hand and remove the screw and disc washer. Use care during this procedure, as the use of pliers or other tools can cause damage to the guiding surfaces and require unnecessary replacement. Do not scratch or mark sealing or guiding surfaces. Remove the seat disc and inspect it. If it is worn, replace the part. These discs are symmetrical. It is usually possible to turn the disc over and obtain an effective seal. Before reassembly of the check valves, be sure to rinse all parts with clean water. Do not use any oil, grease, solvent, or pipe dope on any parts unless instructed to do so. In addition, use caution to avoid damaging any guiding surfaces while handling parts. Do not force them together. Refer to applicable parts lists and figures in the Febco maintenance guide for the Model 825Y for visual aid information. Position the disc in the cleaned holder and retain with a disc washer and screw. Fasten the disc holder with a screw. Reinsert the disc holder assembly and position the spring around the centering ring of the disc holder. To ease cap installation, apply a thin coating of FDA-approved lubricant or pipe assembly lubricant to the O-ring prior to assembly. Thread the cap onto the check valve body with the appropriate sized wrench. Close number 4, 3, and 2 test cocks and slowly open first the inlet and then the outlet shutoff valves. Now, retest the assembly to see if the unit will hold the required pressure differential as indicated by local codes. Restore the valve to normal operation. If your troubleshooting test showed a possible malfunctioning relief valve, slowly close the inlet and outlet shutoffs and bleed off the residual pressure by opening test cocks number 4, 3, and 2. Begin disassembly of the relief valve by removing the cap screws, relief valve cover, diaphragm, and port bushing. Grasp the integral relief valve assembly and pull straight out of the body to remove the internal assembly. To remove the spring and main stem from the guide, first remove the seat disc screw, washer, and seat disc. Compress the unit and remove the flat head screw located in the center of the button. Push the main stem through the guide and remove the O-ring from the main stem. While the valve is apart, check the condition of all parts. If worn or damaged, replace them. Inspect O-rings and seat disc and remove dirt and debris. To service the relief valve seat, while the cover, diaphragm, and internal assembly are removed from the relief valve, remove the 2 Allen head socket cap screws using the appropriately sized wrench. Pull the relief valve body from the main valve body. Pull the discharge shield from the seat ring. Then remove the seat ring with the appropriately sized socket. Use care to avoid damage to the seat edge. Inspect seat ring O-rings, bushings, and gasket seals for damage. Rinse all parts with clean water before reassembly. Lubricate the seat ring O-ring with FDA-approved lubricant or pipe assembly lubricant and thread into the valve body until seated. Do not over-tighten. Position the discharge shield over the seat ring diameter and, taking care not to damage the two flow passages, reinstall O-rings and guide bushings. Place the relief valve body over the bushings and tighten the two cap screws to retain the relief valve body to the main valve body. To reassemble the internal relief valve assembly, begin by lubricating the O-rings and main stem using an FDA-approved O-ring lubricant. Do not use any other oil, grease, solvent, or pipe dope on any parts. Place the main stem and spring into the guide and replace the flathead screw located at the center of the button. After placing the disc washer and seat disc in position, taking care not to disturb the guiding surfaces, depress the diaphragm button to ensure it is free moving. Reinstall the relief valve module and mount the diaphragm, positioning it over the port bushing. Then position the cover and tighten the cap screws. Repressurize the system and bleed the air from test cocks number 4, 3, and 2. Retest the device to ensure it is operating properly and return the valve to service. Other symptoms to troubleshoot include the following. If during field testing it is found that the number 1 check valve is at least 7 psid at all times, it may be that the relief valve seat disc is dislodged from the relief valve main stem. This can be caused by pressure surges during the initial filling of system lines or water hammer. Disassemble the relief valve and reposition the disc in the main stem cavity. While the valve is disassembled, inspect and clean the relief valve seat and the high-pressure hydraulic passage. Check the condition of the seat disc and make sure the main stem and spring button are free moving. Ensure the main stem guide O-ring is not leaking. When these items have been inspected, reassemble the valve and repressurize the system slowly. Retest the device to ensure it is operating properly and then return the valve to service.